Welcome back to my YouTube channel. Today I'm talking about p-values. So p-values are a bit of a controversial topic in statistics. They're not well understood, and people who do genuinely understand it disagree about how important it is. Okay, so what a p-value is the probability of getting a value at least extreme as the one observed under the null hypothesis. So in a t-test, the null hypothesis is often no difference between groups. So the difference equals 0, and then the alternative is the difference does not equal 0. And that's very often the two-tailed hypothesis, so it could be less than 0, or it could be greater than 0. But of course, if you switch the positions of the group you're considering, it wouldn't matter. Okay, so a p-value is the probability of finding a value at least extreme as the one you found, assuming null hypothesis is true. So if our null hypothesis is a group difference is 0, and we get a value of 3 with a standard error of 1, we say that the p-value would be somewhere less than 0.05. Because that a confidence interval made with those values would not include 0. So this is answering the question we want. We start assuming the null hypothesis. Like in law, we start by assuming the defendant is not guilty. We only abandon that assumption when we have sufficient evidence. So it's a good metric. We assume the null hypothesis and look at the data. If the data is more extreme than what we would expect, we conclude that the data may not fall under the null hypothesis, that the alternative hypothesis may be true. Okay, so we frequently use 0.05, and people get really upset about 0.05. 0.05 is arbitrary. We could just as easily use the threshold of 0.1. We could use the threshold of 0.01. But generally, if you don't use it, people are going to really question you. And there's more complexity to that too, like when you're doing a multiple hypothesis test. And I'm sure I'm going to talk about that in a subsequent video. Okay, so if the p-value is less than 0.05, if the probability of finding such an extreme value in the null hypothesis is low, less than 0.05, and low is relative. We're using 0.05 just because that's what everyone else uses. It's not a good reason. That's debatable. But it's what we do. And we also call that threshold alpha. Okay? So here's some things that people think p-values mean, but it doesn't. A p-value of 0.05 means there's a 5% chance the null hypothesis is true. That's not true. We don't get that level of precision in our analysis. We only get that the observed data is consistent or inconsistent with the null hypothesis. And I'm using consistent and inconsistent because it's wrong to say that either one proves the alternative or null hypothesis is true. We don't get that level of certainty. It's really only consistent, inconsistent. And in the common language you would learn in an introduction stat class would be reject the null hypothesis or fail to reject the null hypothesis. You never accept either hypothesis. You only can't say it's different than a certain hypothesis. Okay, so some notes. Yeah, 0.05 is arbitrary. And people get really upset about it. I don't know. I don't really care that much, but it is a major point of contention, especially in psychology. P-values aren't the only measure that matters. You have to have effect size and whether or not it really means very much. A common critique is that if you have sufficiently high sample sizes, you will very often get a p-value less than 0.05. And that's from a incredibly small difference between the groups. And there's also a line of thinking, especially in like the experimental sciences, psychology, that the effect almost never really is 0. It might be 0.0001, but to say it's 0, you always get some effect. If you're coming up with a hypothesis and you don't get an effect, you may be doing some dubious science. But if it's an effect we can only detect if we have a sample size of 5,000 in each group, maybe we really don't care about it. And that's more of a philosophical point than a statistical point, but it's still worth considering. So in conclusion, p-values tell us what we want, but maybe not with the level of detail that we want. We want to know if our data is consistent with the null hypothesis. Just like in a courtroom, you assume the null hypothesis until your data tells you otherwise. And of course, in the courtroom analogy, I'm saying you assume innocence until you have reason not to. Okay? So that's the end of the video. Thank you for watching.